How does EKG paper work? So EKG paper can look confusing at first with the different size boxes and the dark and the light lines. By the end of this video, you're going to understand what all that means and how we use EKG paper when we're interpreting rhythms or looking at 12 leads. So what is EKG paper? So EKG paper is ruled graph paper that is used to measure both time and amplitude. So here is a blank 6-second strip of EKG paper. Most rhythm identification is done with a 6-second strip. That gives you a good snapshot and the ability to see enough beats to have a good idea of what's going on. But we're going to focus on a 6-second strip as the foundation for rhythm identification. So the paper is used to look at time and amplitude. So what does that mean? When we go from left to right, we will see beats across the paper. And from left to right is a certain amount of time. Now, if we zoom into these boxes, we can see that there are small boxes and there are larger boxes. A small box is measured at 1 millimeter by 1 millimeter. When we're talking about time from left to right, one small box is 0.04 seconds. One large box is 0.20 seconds. Taking that into consideration, when you look at this strip, you see that there are lines across the top. Depending on the cardiac monitor, right, this can look different. We see the smaller lines here and then the bigger, darker lines here. The smaller lines are 5 big boxes. So 5 big boxes equals 1 second. And we can see that because we know that one of the smaller boxes is 0.2 seconds. So 2, 4, 6, 8, 1. So we know that one of these small lines is 1 second. That makes one of these larger lines 3 seconds, and the second larger line 6 seconds, which is why this is called a 6-second strip. We know that 5 big boxes equals 1 second, 15 big boxes equals 3 seconds, and then 30 big boxes equals 6 seconds. So as we go across in time, we're looking at a 6-second strip. Why is this important? Why do we need to measure time on a strip like this? Well, it's primarily how we figure out what the rate is very quickly by looking at this strip. Pretend you had only this and no cardiac monitor with a rate on it. To be able to quickly and easily look at this strip, you could count the R waves and multiply by 10. And there's other ways that work as well, but that's a quick and easy way to do it. And we'll look at that in our examples. Now that we have a basic understanding of how time is measured across the EKG strip, it's important to also understand amplitude. Amplitude is the strength of the electrical impulse and its measurement on the EKG paper. Similarly to how we measured time, we look at small boxes and big boxes for amplitude. Remember, amplitude goes up. One small box is 0.1 millivolt. But also remember that the boxes are also measured at 1 millimeter by 1 millimeter. This is 1 millimeter by 1 millimeter, and it's also measured as 1 millivolt. So that would make one large box 0.5 millivolts because there are 5 small boxes, 5 by 5 in each large box. And that would make 2 large boxes vertically 1 millivolt. Understanding the amplitude is important when we're looking at things like a 12-lead EKG and we want to check for ST elevation to see if the patient is possibly having a heart attack or an acute MI. And it also helps when looking at things like the P wave or the atria, right? If the P wave is too tall, that can be indicative of some conditions. Or when we look at the height of the R wave, or the height of the T wave, right? These things could all indicate various conditions that are good for us to note out in the field. Primarily, though, the amplitude for us is going to be really important in identifying those acute MIs. So in this first example, we want to take a look at this 6-second strip, right? And we know that because we see these lines up top, 1, 2, 3, 4, 5, 6. So we know that each one of those lines is 1 second. So this would be a 6-second strip. So like we talked about before, when we're looking at time, we're going to use time to determine rate. We take a glance at this, we see that it looks regular. The R waves look regular, but we want to count the R waves. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So we have 12 R waves. And if we're going to calculate rate based on the method that I mentioned before, we would just multiply that by 10 for a 6-second strip. And that would give us 120 beats per minute. And that's a quick and easy way to take a glance at this and determine what the rate is. There are other methods for determining rate that are more accurate, and they all involve using time or counting the boxes to determine what the heart rate is. Next, let's look at this example and see how amplitude fits into the equation. Remember that amplitude is measured on the vertical axis. What would we use this for? Well, let's say we're looking at a 12-lead EKG and we see these beats and it looks like there's ST elevation. We're going to consider where the baseline is, and then we're going to measure from the baseline to the J point to determine how many millimeters or how many millivolts of ST elevation there is. So in this one, we see there's 2 boxes. That would be 2 millimeters of ST elevation or 0.2 millivolts of ST elevation. Those two things mean the same thing. Same with this one. If we look here, we see that there's about 2 boxes that we can fit in there, and that would be the same 2 millimeters or 0.2 millivolts, right? So for an adult male, we usually look for 2 or more millimeters of ST elevation in contiguous leads to determine whether or not the patient is possibly having an MI. As you can see, that is just one example of how we use the measuring of the amplitude to help us in our diagnosis of the patient and guide our treatment. After you have an understanding of how the paper works and what it all means, the next most important part of being able to identify cardiac rhythms is understanding the step-by-step process that goes into it and to be able to apply that every time as you practice so you can create a system that works for you and you can become consistent in your rhythm identification. And I'm going to show you how to do that in this video.